Hi Zoe, as discussed in class, I will give you a rundown on how to do question 4. Not as hard as I thought it was going to be in a way. And yeah, the key is that we've got a group of 100 families, each with 3 children. So we end up with 300. So we've got this distribution here, and it says, using this sample, estimate the probability that a new baby born is a girl. So what we need to really do, just quite simply, is work out how many girls were born, um, and then treat that as a probability. So it's not too bad. So what is the probability it's a girl? Well, the probability that there is a girl is it's like an expected value calculation, really, in that um, we've got 34 multiplied by 1, so that's 34 families had one child. 40 families had one girl, 40 families had two girls, 13 families had three girls. So in terms of how many girls were there, there's 34 times 1 plus 40 times 2 plus 13 multiplied by 3 all over 150. Oh, sorry, all over 300. Don't know where 150 came from. Now, if you multiply that top, which I did by hand separately, you get 153, which is the answer at the back of the ball. And that's, if you look at the top number there, 5 plus 3 is 8 plus 1 is 9. So it's divisible by 3. So we can actually just convert that directly down to 51 over 100, or 0.51. So we've got a decimal equivalent there if we want it. Okay, next bit. Calculate the number of families in this sample that you would expect to have two girls. So I'm going to treat this more like a binomial distribution at this point. So the first thing I'm going to do is say, well, what's the probability that a family of 3 would have 2 girls to start with? Well, to have 2 girls, you would have to have the first one being a girl, the second one being a girl, and the third one not being a girl. So hence we've got 0.51, 0.51, 0.49. And we can do this because they're independent events, right? But that's specifically girl, girl, not girl. But we could also have not girl, girl, girl. And we could also have girl, not girl, girl. So there are 3 ways of working that one out. So I'd have to multiply that by 3. Okay, so dit dot dit on your calculator, you would get 0.382347, or 0.382 is going to be enough for this particular calculation. The next thing we're going to do is we're going to work out effectively an expected value. What we're looking for is a family has 2 girls. So our condition is going to be a binomial distribution. We're going to choose X, number of families, such that we have 100 families and a 0.382 probability that it has 2 girls. And then we're going to work out an expected value that X is equal to 2. Okay, so 2 girl families. So we're going to use the formula NP for that, which is equal to 100 multiplied by 0.382, and that's equal to 38.2 families. And that's the answer to the back of the textbook. So there's a lot of, this question was very heavy on working out what that probability, or that binomial probability, is. And then once you've done that, you can use your expected value theory to work out the end result. And that's it. Side note, I just paused the video and had a bit of a think and came back. I knew there was something, I felt uncomfortable with this bit here where I said E of X equals 2. That's not how we do it in binomial distributions. X equals 2 doesn't make sense. X is just the value we're looking for, the expected value, therefore, because the binomial distribution already is set in terms of from 100 people, there's a 0.38, from 100 families, there's a 0.382 chance that they have two um, girls in their family. So E of X is equal to NP equals that 38.2 families.